Alright, so in this problem, I have 8 to the power of x is equal to 16. So I want to find the value of x here. So for my solution, I'm going to start by rewriting my equation here. So my equation is 8 to the power of x is equal to 16. Now, before we start doing anything, let's just inspect this problem real quick. So if I plug in x equals 1 into this equation, I get 8 to the power of 1 is equal to 16, which 8 to the power of 1 is the same thing as 8, so I get 8 equals 16, which is false, right? Now if I plug in x equals 2, I get 8 to the power of 2 is equal to 16, and 8 to the power of 2 is 64. So I get 64 equals 16. And notice how there's a big gap between 8 and 64. So we know that the value of x is not going to be a whole number but a decimal, and it's going to be somewhere in between 1 and 2. So x is greater than 1 but less than 2. We know this. Now, how are we going to actually solve this problem and find the exact value of x? Well, what I can do is rewrite 16 as 8 times 2. Now what I'm going to do is divide both sides by 8. So then these two cancel out, and I get 8 to the power of x over 8 is equal to 2. Now if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So a to the power of x over a to the power of 1 is equal to a to the power of x minus 1, which is equal to 2. Now a is the same thing as 2 to the power of 3, so I get 2 to the power of 3 to the power of x minus 1 is equal to 2. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of x minus 1 is the same thing as 2 to the power of 3 times x minus 1. And 3 times x minus 1, I can distribute 3, so I get 2 to the power of 3x minus 3 is equal to 2. And 2 is the same thing as 2 to the power of 1. And if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So this means that 3x minus 3 is equal to 1. And now if I add 3 on both sides, I get 3x is equal to 4, and x is equal to 4 over 3. Now, there actually is another way to solve this problem. What I can also do is at the start rewrite both of these in bases of 2. So 8 is the same thing as 2 to the power of 3, so I get 2 to the power of 3 to the power of x, and 16 is the same thing as 2 to the power of 4. Now this is the same thing as 2 to the power of 3x is equal to 2 to the power of 4, meaning that 3x is equal to 4, and x is equal to 4 over 3. So this is a much simpler method of solving this problem. Alright, so in this video, I'm going to be solving the problem 2 to the power of 101 minus 2 to the power of 100. So to solve this problem, I'm going to first start by rewriting 2 to the power of 101 as 2 to the power of 100 plus 1. Now, the reason I did that is because now I can use this property that states that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of 100 plus 1 is going to equal 2 to the power of 100 times 2 to the power of 1. And now I have this minus 2 to the power of 100. Now from here, I can factor out 2 to the power of 100. So I get 2 to the power of 100 times 2 to the power of 1 minus 1. Now 2 to the power of 1 is equal to 2, and 2 minus 1 is 1, so I'm left with 2 to the power of 100 times 1, which is equal to 2 to the power of 100. Now, there is actually another method of solving this problem. So going back to the problem, I have 2 to the power of 101 minus 2 to the power of 100. Now, before I rewrote 101 as 100 plus 1, but how about I rewrite 100 as 101 minus 1? So now I get 2 to the power of 101 minus 2 to the power of 101 minus 1. And this is the same thing as 2 to the power of 101 minus 2 to the power of 101 plus negative 1. Now, if I use that property again, that states that a to the power of m plus n is equal to a to the power of m times a to the power of n, I get 2 to the power of 101 minus 2 to the power of 101 times 2 to the power of negative 1. And now if I factor out 2 to the power of 101, I get 2 to the power of 101 times 1 minus 2 to the power of negative 1, which is equal to 2 to the power of 101 times 1/2, which is equal to 2 to the power of 101 times 2 to the power of negative 1, which is equal to 2 to the power of 100. So that's the second method of solving this problem.